Welcome to The Explainer. Today, we're going to pull back the curtain on a discipline that ensures all the technology you rely on every single day, from your car to your phone, is built to be safe and reliable right from the very start.
Seriously, think about this for a second. When you're talking about something like a car's airbag, there is absolutely zero room for error. It can't work 99% of the time. It has to be perfect. So, how do engineers actually pull that off? How do they get to that level of absolute certainty?
Well, the answer isn't magic. It's a relentless, data-driven focus on quality. It's all about making that huge shift from just, hoping a product works to statistically proving it will. And yeah, this really lays out the two worlds, right? On one side, you have engineering without data, which is basically just guesswork. That leads to waste, inconsistent products, and a ton of risk. But on the other side, we have Statistical Quality Control, or SQC. And that is the whole practice of using data to build reliability and safety right into the process itself. It's really the foundation of modern engineering.
Okay, so to make all those data-driven decisions happen, engineers need, well, a powerful copilot. And for countless professionals out there in the field, that copilot is a piece of software called Minitab.
At its core, Minitab is this incredible piece of software that just makes complex statistics accessible to everyone. Fun fact, it was actually developed as a teaching tool way back when, but it proved to be so powerful that now it's a total industry standard for engineers and quality experts.
So you can think of Minitab as the tool, and Statistical Quality Control is the discipline. SQC is like the guiding philosophy. It's this idea of using data to constantly monitor a process, spotting these tiny little deviations before they ever become major problems. And this right here, it perfectly sums up its role. Minitab basically gives engineers superpowers to cut through the noise of huge datasets, find patterns that actually mean something, optimize their processes, and, ultimately, make sure every single product meets the strictest industry standards out there.
All right, so we get what Minitab is, but how does it actually work? Let's dive in and explore 3 of its most powerful tools that engineers are using every single day to guarantee quality.
First up is the control chart, and honestly, this is one of the most fundamental tools in the whole quality control playbook, and for a really good reason. The best way to think of a control chart is as a watchdog for your process. It's a simple graph that just keeps an eye on things over time, and it starts barking the second anything starts to drift off course, even a little bit. It's all about making sure your process is stable and predictable.
And, just like a mechanic has a whole toolbox of different wrenches for different bolts, Minitab has a whole suite of different control charts for different jobs. So whether you're tracking an average measurement, the percentage of defects, or even just the number of flaws per item, there is a specific chart designed for exactly that task.
And you know what the best part is? Minitab makes this whole process so incredibly simple. You just collect your data, pop it in, and with just a few clicks, bam! You have this powerful visual tool ready for analysis. It takes these super complex statistics and puts them right in the hands of the people on the factory floor.
All right, let's move on to the next tool, which kind of builds on this idea. So once you know your process is stable, the big question becomes, is it actually any good? And that's exactly where process capability analysis comes in. So if the control chart is like the heartbeat monitor, think of this analysis as the full-on physical exam. It's what determines if your process is fundamentally healthy enough to produce parts that meet the design specs time after time after time. It does this using a few key metrics. You can almost think of it like a pro athlete, right? Cp and Cpk, they measure the athlete's potential, like how fast they could run under perfect conditions. But pp and ppk, they measure their actual performance over a whole season, including the good days and the bad.
So here's the bottom line. An engineer can literally measure just a handful of engine parts, plug those dimensions into Minitab, and boom, they know instantly if the entire manufacturing line is actually capable of doing its job right. I mean, that's just incredibly powerful.
And that brings us to our third and final key tool for today. This is the one you pull out when you want to make a change, or you have to choose between a couple of different options.
Hypothesis testing. It's basically the scientific method, but for engineers. It's how you can prove whether a change, like trying out a new, stronger material, causes a real, meaningful improvement, or if the difference you're seeing is just random noise.
And no surprise here, Minitab has exactly the right statistical test for whatever question you're trying to answer. Want to compare 2 materials? Use a t-test. Comparing 3 or more? That's ANOVA. It gives you the power to make these confident, data-backed decisions instead of just going with a gut feeling.
And this is a perfect example of that in action. So instead of an engineer just saying, I think this new material feels stronger, they can use Minitab to prove with statistical certainty whether it truly is. This takes all the guesswork out of innovation.
Okay, so let's zoom out for a second. We've looked at the tools up close. Now let's see why mastering them is such a total game changer across entire industries.
We started this whole thing with an airbag, right? And that's just the tip of the iceberg. From automotive to aerospace to chemical engineering, these are all high-stakes fields where failure is simply not an option. Minitab is a critical, non-negotiable part of the process that ensures safety and reliability.
So really, the takeaway here is pretty clear. For an engineer, getting good with a tool like Minitab isn't just about making a few charts. It's about making smarter decisions, getting rid of waste, building better and more consistent products, and at the end of the day, upholding the absolute highest standards of quality and safety.
Which brings us to one last thought to chew on. We've seen how data completely revolutionized quality control. But now, as AI and automation get woven deeper and deeper into manufacturing, what's the next frontier? I mean, what does it look like when a process doesn't just monitor itself, but can actually predict and prevent an error before it even has a chance to happen?